I'm Sodio from the Kaohsiung Medical University. And actually, I get my PhD degree in Taiwan, but I went to the United States for postdoc research. And let's talk about my research. My research is a goal for simple and rational design based on the coordination chemistry. If you are a chemistry major student, you probably learned the coordination chemistry before. So one of my research topics we're talking about, we want to do something structural and functional model for the metallo-protein active site. And second, we try to use this one to design some metallo drugs. Which one we want to know the understanding the power of the coordination compounds. And the third one is my personal habit. I like to play the Lego. So usually I also set up or push some students to study the Lego game in chemistry. We will talking about later. For the first one, we call the bio-inspired coordination chemistry. My goal is we want to understanding some biological reaction from the chemistry point of view, not from the medical doctor's point of view, because we know that every life or every world is made from the chemical molecule. So the best to understand the world or any material you can from the chemistry point of view. So based on this one, we can study some enzyme. For example, this kind of enzyme we call the copper nitride reductase enzyme. They can catalyze some nitride become to NO. So we study by this reaction, we can design some copper compound and making they can release NO as well. So we publish numerous papers under this area. In my lab, we probably is the leading group in this area. So we publish so much paper in this area. Even so, we patent some catalyst reaction. They can easily convert nitride to NO by the 100% yield.
Wow.
Not only of that, we also plan to understanding how the copper in the biological system, how they trafficking. So we designed a very simple model to understand how the protein, they can deliver copper to the other protein too. Not only of that, just I mentioned before, we try to design, become the drug dealer for medical doctor or pharmaceutical. So we're making some drug, use our design. So we also publish several papers, and I will mention that for this one, the JB Harry Babu, this one of my India student. Now he is be a professor in the Chile, in the South America, Chile. And also, not only that, there's the one India lady, he's the daughter Priyanka. She just get a PhD degree from my lab. And not only that, so we try to design this kind of the leucinium anti-cancer compound. Try to use this one to develop some next generation one. And I also combine, I just mentioned my first research topic, nitride and the leucinium one. Now we can easily use the leucinium to cure cancer, also provide some NO for some healthy or for some any kind of pharmaceutical purpose. And for the third one, I just mentioned it before, I like to play Lego. So if you know the Lego game, so did you ever thinking about you learn the bond length and bond distance from the general chemistry? So you can build up the square or the hexagon or the cubic by using some well-designed chemical reaction. If you can do that, this kind of technique is real for future nanotechnology. Now, most of the nanotechnology, they synthesize the gold nanoparticle, silver nanoparticle, but they never thinking about actually the bond distance is really less than nano size. Everyone know the Taiwan semiconductor. They are pretty well to doing some some 3 nanometer technique, 2nd nanometer technique, but actually for the future, for the next generation, for Taiwan semiconductor, they should be go to the how to construct the really nano technology, which is you can design the Lego game for chemists to play it. So for understand this kind of the Lego game, we have been playing the molecular cage in here. You can see the cartoon, the cage is surrounding. Then this cage is the first anion cage in the world. I published this in the 2008. This is the first cage, anion cage. And even we can construct a molecular rectangle, which is the 4 ion inside. That's the also pretty good one. So final one, I want to talking about, give some advice for who want to be the graduate student, especially for India student. You want to be the graduate student, which is be a researcher. The first one, you should read it. The reading is getting knowledge from the textbook. Textbook, they're getting you the very fundamental aspect to understand it. This, and not only the textbook, also the literature research. You should understanding the what important in the past. Then you can know what's the research question going on. People have been done which before, but actually the some question is still here. You try to solve this question, try to find in the new properties, new compound, new chemistry. Then they can contribute to the chemical society. Then you can apply this knowledge to explain on your observation, on your experiment. This is what I usually call in the designation and realization process. And later you have some great finding. Then you should sell. You should write a report, write a paper. So you should also should have some writing manuscript. The English writing skill and scenario design is very important. What's the scenario design? When you watch the movie, you look at the movie, you know the actor, how they play, how they do, they always based on the good story, always based on the writer. That's what we call the scenario design. Scenario design will make your manuscript, make your report more attractive. And then you are easy to convince the reviewer and the community your contribution. So this some of my sharing for the today's students. And usually my lab focus on the copper and iron. So in the copper, so usually I will ask a student, you want to be the bio copper man or supramolecular iron man? Usually this is the copper man. In the Chinese Kung Fu, we usually say it's a copper man. But if the iron man looks much cooler than copper man, however, I will welcome you to join my lab. Okay, thank you very much.